data types. Now, like I told you, right, in the first go, that again, if you have to write a logic or something, right, there would be a need that you need to work on a piece of value or a variable, right? Now, how do you create that variable in Java? The syntax is this. You have to write first of all the data type. Okay, the data type which that variable will hold. So it will be the variable name. Then you will say equal, and then you will assign a value. Okay, that is how you will do it. Okay, so data type is like you will say, let's talk about int value, right? So it is int, right? I want to hold an integer value. Let's say the age, right? So what I'll say is age again. Age. Okay, let's not talk about age. What can I give example? I think okay. Let's talk about age only. So what I am saying is that you will be giving, let's say someone is of age, let's say 10 years, right? 15 years, 30 years, right? See, all these numbers, right? What I'm trying to emphasize is that all these numbers are like whole numbers, right? If you want to hold such a value, right, into a variable, right, then you should be using a data type which is of type int, okay, an integer value. Okay, so what a value I can assign to this age? You could assign 10, you could assign 0, you could assign 50, right? But let's say you want to assign, let's say someone is of age 10 years 3 months, and let's say you rounded off to a decimal value, let's say 10.4, right? 10.54 years, let's say. Then if you intend to provide this value to this, right, 10.4 to a variable who's of type int, then this is not correct. Okay, since this is a decimal value, right, what you should use is you should use a float variable. Okay, you should use a variable type, just a second, you should use a variable type which can support holding a decimal value. Okay, what are those values in Java? Those are type in Java. There are two. One is float. Okay, other one is the double. Okay, now apart from this, right, let's say, okay, let me assign the values. Let me say float, and let's say height. Okay, let's say height. So height would be, let's say, 5 foot 4 inch, right? Let's say I'm providing in the format of a decimal thing, so I will provide like this. Now you would see me writing f here. Okay, whenever you are trying to assign a value to a variable which is of type float, right, you have to add f. We'll talk more about this, right? I'm just trying to give list down some examples to tell you like what all is possible. So these two are used for working with decimal values. Okay, similarly there is a family of integer values, like int is one of them. There are three more: short, byte, and long. Okay, all of these can hold integer values. Okay, we'll talk about what is the difference. So this belongs to the integer value, the whole numbers, right? So this is for the decimal part. And when we talk about character, right, I think we talked about the character part. If you have to store alphabets, right, what you can use is a single alphabet. You should use char there, and then you can write, let's say, initials, right? Let's say name initials. So I will assign a value. Let's say it will be given in a single quote. Okay, in a single quote, and you can assign a, or right, or similarly you could assign any other value, let's say a, small a here, right? Both are fine, but understand that you will be assigning only a single character, right? That is what it means by character. Okay, so these are all numbers here, right? These are all numbers and these are characters. Now moving ahead, right, if you want to hold a second. Okay, so we have boolean, right? If you want to hold a boolean value, so what you should do is you should write here boolean. Okay, and after the boolean you should what we say, let's say variable name, right? Let me give it a variable name as is valid, right? What you can do is you could assign the value as true or false, right? So for these kind of needs, you would be creating a data type of what? Boolean thing, right? Integers, decimal, character, Boolean. Okay, what else? What else? Okay. Now, everything which I've written here, right? Everything which I've written here, these are all categorized in a category which is named as primitive data type. Okay, primitive data type. Okay, please remember this terminology, primitive data type. Now, what is primitive, right? We'll talk about. But try to understand these are all part of primitive data types. What are these? We'll get into it. Let's try to understand one more thing, right? Let's say I want to store the complete name of a person, right? So which is like characters, but it is like more than one characters, right? Like Akhil Jain. So what I need to do is I need to have a variable, let's say name, which will hold my name, right? Akhil Jain. Now see here, for writing this, right? I need to know what should be the data type here. Which data type should I use? Now you cannot use char because char is used to only hold a single character. So the data type which is used in this case, right, is would be string. Okay, string name Akhil Jain. So that is what you will use here. Now there's a big difference. There's a big difference, although it will not. I mean, it will not be very visible in the first go. But try to understand here, right? If you would see this S here, right? S is capital here. Okay, I will show you in the program also. But and if you see all these things, right? I, F, D, char, boolean, right? These are not capital. Okay. Now, if you remember, right, I told you yesterday that there is one thing in Java that you should start with the capital thing, right? And it should follow the camel case pattern. What is that thing, Sally? If you know, if you remember.
Yeah. When we're joining two different words, then first letter of every word will be capital. For example, Akhil, and then A and J will be capital.
For what? For what? Is it the rule? I mean, that is the nomenclature for which kind of I mean thing here, right? It
Yeah.
would be it would be for a class, method, variable name. What is that thing? Where you
It will
where
be
you
for
need to create
class.
class, right? Class,
Yeah.
right? Everyone, it should be for the class. Now you have to understand here, right? This string here is a class name. Okay, you did not create it. I did not create it. This was already created by Java and provided to us. Okay, so if you would see in Java, string is already a class. Okay, it's a class. Okay, and over here I am using this class as a data type, right? Everyone, I'm using it as a data type. Now come back to this part. Here int, float, double, char, boolean, right, are not classes. Okay, these are not classes. Okay, and these are the only things in Java which are not classes. Remember my words, right? You will realize this when you will work on Java. Okay, once you start doing a lot of things and hands-on on it, you will realize that in Java there are only handful of things which are not classes. And what are those things? Only these data types: int, short, byte, long, float, double, char, boolean. And all these falls, and that's the reason, right? What we are doing is we are terming them as primitive data type, right? So they fall into a category of a data type which is termed as primitive data types. So primitive data types are those data types which are not classes. Okay, which are not classes. Everything else in Java, you would find that those are only classes, nothing else. Okay, we will refine that statement later on. But when it comes to like this thing, right, all these parts you have to remember these are not classes here. But I gave you an example, like there is a class string in Java which you could use as a data type also, right? And you can see I'm sure like a lot of people would have already used this, right? Like this. Okay, but again, the core part here is that if you want to hold more than one character, right, like a word or a statement, right, what you should use? You should use a variable which is of type what? String. And string is what? String is a class in Java. Okay, now let's see some examples, right? And let's try to understand what is the difference between float, double, int, short. See, this is very straightforward, right? If you want to hold a single character, then we are perfectly fine because there are no multiple options here. So I think we should be good with this char, we should be good with this boolean, and we should be good with the string also, right? Because the purpose of using these variables are very clear to us. What about these things? Why there are four options, and which one should I use if I want to hold a value of say age, right? Which one should I use? Similarly here also, if I intend to hold a decimal value, should I use float or double, right? Let's try to understand that question here. Now, try to understand, right? You are working on a program and you are using a computer, right? Now, if you want to store something, right, it would be stored somewhere in the memory, okay? And memory is not free, okay? Memory is not free. You have a limited memory which you would be using, okay, which your system may have. It's not that you have infinite memory and you do not care about the memory part, okay? That is not the case. So memory is limited. We should all remember that part. Let me write in the right sequence for the int family. First of all, how things starts is, it is byte, then we have short, then we have int, and then we have long, okay? Now, in programming world, right, you all, I think you all would have remembered that statement that computers only understand two things, that is 0 and 1, right? 0 and 1 only. Computers
Yeah.
understand only these two values, 0 and 1. Anything you write, be it in Java or be it somewhere else, right, everything in the end will will get translated into 0 and 1 format only, and that is what our computer understands, okay? Now these are called words, right? This 0, if you use, it's a single bit, one bit, okay? So bit is like a smallest unit which you can have, right, for the memory. Let's say, I don't know, like if you can have even a smaller value than bit. At least I am not aware, okay? If someone is aware about it, let me know. But what I think is, bit is the smallest unit which you can hold in a memory, right? So 0, if you use this 0 here, right, so this is like one bit, it will hold one bit, right? Similarly here, for this one, right, it is also represented by one bit, right? Now, if you understand this part, right, then try to understand here that 1 byte equals to 8 bits, okay? So it is like you will have a memory space which will occupy 8 bits in your memory. 1, 2, 3, 4, 5, 6, I believe 1, 2, 3, 4, 5, 6, 7, and 8, right? So these are 8 bits, okay? In case of short, it can occupy 16 bits, okay? Again, 16 size, whatever that things would be, right? 16 bits. In case of int, it occupies 32 bits, okay? 32 bits. In case of long, it occupies 64 bits, okay? 64 bits. Now, how does it matter to us, right? Whether it takes 8 bits, 16 bits, 32 bits, or 64 bits? Why does it matter to us, right? First of all, we should be knowing this also, right? Now, okay. 64 bits, okay. Now, okay. I think, see, okay. If you have an 8 bits thing, right? If you have, if you have, if you want to store in a byte, right? You have to understand like what is the data range which it can store within it, using this 8 bits, right? If you try to store something which is of 9 bits or more, right, and if you try to store it into a byte, it will not be stored correctly. Why? Because if that value is translated into a 10 bits or 11 bits thing, right, then you would be losing those bits, right? And then, because a byte can only store 8 bits, okay? Now let's first try to understand like how do you convert this things into a bit, right? Okay, again, this is not necessary for everyone to be aware of, but I'm just making sure that you understand the depth of it, okay? It is not like and if you don't understand this, then you will have a problem in Java. No, right? If you understand this part also, right, that a byte stores 8 bits, stores this, then this is also fine. But let's try to go there, right? Let's try to answer that query also. 8 bits, right? Let me think. Okay, 8 bits. Let's say if I have to, actually I'm not remembering the calculation which we do, but what happens is this is something like this, I believe. If you use 2 here, right? How, let's say you want to store a value 64, right? And let's say I wrote something like this: byte age equals to 64. Let's see, can we store this value 64 in byte, or do we, I mean, we have to see like how much memory space this value of 64 will take in our memory space. Okay, let's think about it. So this 64 will be translated into the format of 01, right? And then once it is translated into 0101, whatever that value would it translate into, we will have to see whether those it generates within that boundary of 8 bits or not. If it does not fits there, right, then we cannot use this value. I mean, we cannot store 64 inside a variable of type byte. So we should use a bigger data type which can store a bigger value. So in that case, we will move to short, and then we should use short. Okay, that is how it is. Let's try to learn this. Okay, even I don't remember completely, but let's see. If you have to convert, right, a value into bits, right, I think this is how you do it. 2 is to 66, right? Right. So it is like, but I just wanted to show the process also. uh, how do we do it?
It was part of digital electronics, I guess, and
Yes.
multiplexes and demultiplexes, I believe.
Right.
So we used
Actually,
to,
right.
yeah.
So that is how it is. But again, uh, let me think actually what we do.
Well, I also don't recall it correctly, but as far as my memory goes, so it was like that
Mhm.
one bit can have two values, either 0 or 1, right? So the number of so the permutation and combinations then that one bit can go is 2, right? And if your byte is 8 bits, so the maximum it can store is 2 raised to the power 8. That is the maximum combinations it can achieve. Now,
Hmm.
these can be negative numbers also and positive numbers also. So the range would be minus 2 raised to power 7 to positive 2 raised to the power 7.
2 raised to the power 8, right? I think it is -1 here, and it is still the this part, right? Let us check on Google, right? I don't remember this part. Let's see. Uh, uh, data range for byte variable in Java. Let's see. Yes, -128 to 127, right? And how does it translate into this? I think it will translate into, if you would see, right, 2 into 2 is just into 4, right? It is, then if you multiply into 2, it's 8, 16, 32, 64, and then this is 128. How many bits we have used? 1, 2, 3, 4, 5, 6, 7, right? 7 are used. Now the rule is you have to use n, right? N minus 1. So this is like n minus 1 here,
Minus minus
2
2.
raised to the power n minus 1, right? This is how it is used.
No, no, just let me write it here. So minus 2
Uh,
um, caret n minus 1 2 plus 2 caret n minus 1. I think this is what it is, because see, the total number of values it can store is 2 raised to the power n, right? If it is
uh,
n bits long, and these values can be negative and positive as well,
uh,
right? So that is why minus 1. So why, so minus 128 is, so 128 is 2 raised to the power 7, right?
uh,
So minus 128 to plus 128, for example, or 127 for that matter. So it's like, I mean, the total values is 256, right?
uh.
If you make a sum of the positive numbers and the negative numbers, it comes out to be 2 raised to the power 8. So that
Ah,
is
right,
the
right, right,
maximum it
right.
can store, including 0. That is why the positive count is 127.
Absolutely right. No, you're absolutely right. This is how it works, right? And you're absolutely right on this. But to find the range of it, right, the formula of the range is this: that it starts from -2. You have to use n minus 1 just and not just n, right? And then
Yeah.
from n minus 1, you, so what this counts to, right? Let's say you fit 8 here, right? What will happen? Minus 2, 8 minus 1. What it translates into? It translates into minus 2 raised to the power 7. And minus 2 raised to the power 7 means minus 128. Okay. And what does 2 raised to the power 7 means? It means this, multiplying 2 7 times. Okay. And 1 2 3 4 5 6 7, so it is 4 8 16 32 64 128. Okay, that's why it shows this value. Then, and then if you would check the extreme right side range of it, so range is something like this, right? So you're saying if you want to store a value into a byte, right, you can store how many, so what are the number of bits? You can store 8 bits. Okay, now what value can have 8 bits, right? So how many values can have? We will take it from a center place, right, from 0, right? And then we need to understand from the right hand side where we can go and left hand side where we can go. So the range is like this, minus 128 to 127. How did we find this number? We do it like here, n equals to 8 here, right? N equals to 8. So the formula is minus 2 n minus 1, right? And the extreme end is 2 raised to the power n minus 1 minus 1. Okay, so this is the formula. But what is the key takeaway here, right? The key takeaway is that if you want to use a variable, if you want to store a variable and you assign data type as byte, then the value which you can store inside this are only from, I mean, the value which can store inside this are only these, right? So this value, it cannot store 128. Okay, that is what it means. Okay, now again you would find, right, that in your case you will have to use a int value which could be even bigger than 128, right? So byte is something which people does not use very often. Okay, so will not be using it. Similarly, if you talk about 16 bits, then what is the formula? The formula looks like this. You will have, again, as Atul said, you can have 2 raised to the power 16 values. Okay, I mean the different types of value which you can store. Again, I don't know like what is the value there, but if the rule here is, it would be like minus 2 raised to the power 15, and it can store till the value of 2 raised to the power 15 minus 1, whatever that becomes to, right? Let's see this also. So if we check about short, you can see that this is the number 32,768 to 32,767, right? If you try to store something else into it, right, apart from these values, it will have a problem. You will lose out some of the bits, and it can change, and it can I mean behave strangely there, right? And also see, let's try to convert our values into this format, right? Let's convert int value into bits, right? Let's see how, what is the process. I don't remember completely. To convert an integer to binary, divide the number by 2 until it becomes 0. In each step, take the modulo of by 2 and store the remainder into an array of stack. Okay, so what we have to do is, let's talk about 126, right? Let's say I want to store a value of 126. How will I do it? I will do something like this. Let me open a new tab. 126. So it is saying take a modulo of by dividing it by 2 every time. Okay, so let's say 126, and here what do we get? We get
63.
it would not, okay, it would be like 63. Yes, 63, right? So we got 63, and what is the remainder if you divide 126? 0, right? You get 0 remainder because 126 is totally divisible by 2 here, right? So you will get what? You will get 0 here. Okay, we have to form 8 bits, right? Let's say we want to form 8 bits here of this. So let's see. So the first bit here is 0 now, right? Let's now see, is 63 divisible by 2? No, right? 63 is not divisible by 2. Where it will fit in? You will get what? You will
31.
get 31, 31, 31. Yes, 31,
31
right?
and modulo 1.
31, and then you will get 1 as a remainder, right? If you multiply 31 into 2, what do you get? 62. 31 into 2 is what? 62, right? So you would write 62 here, right? So you are getting what? You're getting 1 here as a remainder. So I write it 1 here, right? So here in these boxes, right, you have to write remainders, right, until and unless all these numbers translates into 0 in the end. Okay, that is what it will have to do now. And over here we have to type the number by which we divided it, right? Now 31, right? Is 31 divisible by 2? No, it is 30, right? Which is the closest match to that number. So here also you will get a remainder like 1. So you will add 1 here. And you got what? You now what did you multiply it with to get 30? 15, right? So use 15. Now is 15 divisible by 2? No again, right? It is the closest match is 7. Sorry, 14, right? And it came by 7. And what is the remainder in this count? 1. So you will add 1 here. Now 7. Is 7 divisible by 2? No. 6 is the closest match. So again, and what did you multiply it with? 3, right? To get 6. And the remainder is 1. So add the remainder here. Then again, you'll have 3. Again, the closest match is 2. What did you multiply it with to get here? 1. And what is the remainder? Again 1. So you will add 1 here, right? And now, is 1 divisible by 2? No. But the closest match is 0, right? So here, the remainder left is 1. Did we got all 8 digits or not? I think no, right? 1, 2, 3, 4, 5, 6, 7. Okay, I think we did something wrong. Let me just grab it again. And in the end, we use 0 also. Okay, let's see.
No, I think we are right, Akhil, because we did 2 raised to the power n minus 1 because it would also allow you to store negative values, right?
Okay, let's start. Okay, let's say that this is the binary value, right? Let's translate into a int value, right? How do we do it? This is simpler actually. This is much more simpler than this conversion. You have to do something like this. What you will do is, this is your index position 0, 1, 2, 3, 4, 5, 6. I was expecting that there should be 7 also. Let's check actually what value it results into. So
Acha, right.
how it works is, yes, how it works is that you have to use 2 raised to the power 0. So what is 2 raised to the power 0? It is 1. Okay. Now here, right, if you have to get a value for it, you will do 2 raised to the power 1. What do you get here? 2, right? We will add all these numbers which I am circling, okay, to get whatever number we get in the end. Now one is, now here the index position is here 2, right? So we will write, see, the formula is that you will write okay, 2 raised to the power 2 here. And what we do is, we multiply it with this number, right? Whatever we have, 1. So here we will get 4 here, right? 4. In this case, we have 2 raised to the power 3. So which comes out to be 8. Here we have 2 raised to the power 4. So it comes out to be 16. And here we have 2 raised to the power 5, which comes out to be 32. Now add these numbers. 32 plus 16, 48. 48 plus 8 is 54. 54 plus 4 is 58. 58 plus 2 is what? 58 plus 2 is 60. And 60 plus 1, right, is 61. That's why I was saying that one number is missing, right? So it is still not 63, right? I mean, it's still not 126. Okay. Okay, let's take an example. I am not very good in this. Okay. So let's see this. So how to convert this? Java program? No, I don't want to see this. Let's see how to convert it into a bit. Yeah, I think their stack flow would have shown us. Let's see this. I just want to see the logic. Okay, man, accept all cookies. No, this is not right. Okay, let us see. Let's go to our maths basic. Okay, so we'll convert number into binary into binary calculation. Okay, let's calculate this calculator. Divide the number by 2. Okay, Khan Academy. Let's use Khan Academy. Continue to divide the result by 2. Stop until the result is 0. The binary answer is the remainder. Read it from bottom. Okay. They will show a video to us. Okay, I don't want to see a video. To convert a number from decimal. Okay. Okay, just a second. I know it is taking too much time. Just give me.
You can directly put it the converter from binary to number to binary converter. I mean, search bar.
Okay, no. Okay, see here. See, I just wanted to show you the process also, right? See here. It's saying that divide the given number 13 repeatedly by 2 until you get 0 as an equation, right? So let's see here, right? If you want to convert 13 into your binary value, right? So see how they're doing it. Again, we first divided 13 by 2, we got 6, right? This is the output of the division, 6 here. What is the remainder? 1, right? Similarly, we use 6 here as an output, we use as an input, divide by 2, we got 3, then 0, and we put 1 0 1 1 here, and then this is a decimal representation, and this is the binary representation. So in a similar way we'll do it. And if we have to convert binary to decimal, how do we do it? Have they shown that also? Decimal to binary? They have not. Binary to decimal also. Okay, nothing here. Let me check it. Pumber.
Seems like we were doing it correctly, with the only exception that we started writing the remainders from
from right.
And here in this example, we are taking them on the right side.
Right. That is where the problem was. Okay, let me try it again. Let me give it another attempt. Okay, so let's see. So what I'll do is, let me use the process which they also use. So we are dividing 126 by 2. What do we get? We get 63, right? What is the remainder in this? 0, right?
Sorry.
0, right?
Zero,
the remainder, so it will have the remainder, and this will be like the multiply part, right?
Hmm.
So if you multiply 2 into 63, you get 126, and there is no remainder left, right? So this will go to the extreme end. So let me start filling this. So 0 will come here, right? This is what they did, I believe.
Yeah.
Right. So I think, let me just reconfirm it again. I believe that was the part. Yes. So the end one was placed here, right? In the end. Okay. So now we have 63, right? Use 63 here. We will do it until we get multiply as 0, right? We'll keep doing it. So here, if you multiply 2 with 31, right, you will get 62. So that is the closest match. And here the remainder would be 1. So we have to write 0 1 here, right? Now we will use 31, and then we will divide it by 2. Now what is the output? The multiply part is the 15, right? The closest match is 30. So 2 into 15 is 30, and the remainder would be left as 1. Right? Every time the remainder would be like 0 or 1 only, right? It cannot be more than that, because you are dividing a number by 2. Okay. Now 15 here, right? Use 15, and if you divide by 2, what do you get? You get 7, right? And then again one more remainder. Then you have 7, and then you use divide by 2. You have what? 3. Then again you have one remainder. If you use 3 here, you use divide by 2. You have you will use 1 here, right? And again you will have one more remainder. And if you divide 1 by 2, you need 0, right? 2 into 0 is 0, and then you're left with one remainder, right? So this is the output. We did the opposite way, right? 0 1 1. So Atul is right. What we did was, we wrote it in a reverse order. We were doing correctly, but I think this is a better way of explaining. So I think it would have made more sense. So 0 1 1 1. So how many ones are left? 1 2 3. 1 2 3. Now you can see, right? As of now, to write this 126, right? 126, we required 7 bits. 1 2 3 4 5 6 7, right? One decimal bit, right, is for that signage thing, right? That whether it's a positive number or a negative number, right? That is where you leave that part here, right? But let's try to convert this value first, and then I will talk about that part also. So this is the binary representation, first of all, right? This is the binary representation of our decimal value of this, right? So this translates into this, which is like a binary representation. This is how you write 126, a decimal number converted into a binary like this. Let's reconvert our binary value into the decimal value. For that, the process is, you will use this value, okay? And then what you will do is, you will say, I think you will use this, whatever it is written here, right? 0 or 1. You will use 0. You will multiply it by the index position. So this is 0 position. 1 2 3 4 5 6. Okay. And 7th is, we do not have anything. So you will say 0 into 2 raised to the power 1. Here you will write 1 into 2 raised to the power 1. Here you will write 1 into 2 raised to the power 2. Here you will write 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, and then you will write 2 raised to the power 6. Okay. Let's see if we get this. I am not sure. So 2 raised to the power 6 is what? 64. Oh, yes, we are trying to get 126, right? So it should be great. 64, 32, 16, 8, 4, 2, and this is what? 2 raised to the power means 1, I believe, right?
Zero.
But 1 into 0 equals
0.
0, right? It
Yeah.
becomes 0 there, right? Now let's add these numbers. What do we get? I hope we get the right number. 64 plus 32 is 96. 96 plus 16 is what? 112, right? 112. 100, am I right? 96 plus, yes, 112. Then you add 8. Okay, let's add these number first. 8 plus 2, 10. 10 plus 4 is what? 14, right?
We're getting it.
So,
126.
what do we get? We get 126, right? And so again, you will say, Akhil, we got only 7 bits. 1, 2, 3, 4, 5, 6, 7, which is fine. The last bit is for the signage part, whether it's a plus or a negative number. Okay. Again, I'm not trying to teach you here how to convert the binary into decimal, but I just wanted to show you that how the system would be doing internally that conversion part. Okay, this is what they will be doing, and this is for the numbers here. But again, there are alphabets also, there are other things also, the special characters and all. In those cases, the ASCII value is used, okay, to do that representation. But again, we do not have to go there. But I just wanted to explain you like how that internal things happen with just one example. Right now, you can see, right, if you have a number 126, you need this thing. If you use a number like, let's say, 512, let's try to do this, right? Let's try to create this one also, and you will understand what I'm trying to say. If you divide by this 2, right, what you will get? I think you will get 256, right? And the remainder would be 0. Then you will use 256 to divide by 2 again, and you will get what? 128. You will get again remainder is 0. Then you will use 128 to divide by 2 again. You will get what? 64. Again 0. Then 64 divided by 2, you will get 32. Again 0. Then you will use 32. Again divide by this, you will get 16 and 0. You will use 16, you will get 8 and 0. You will get 8 and divide by 2, you will get 4. Again 0. Oh, everything is 0 here. Okay. 4 and 4 is divisible by 2. Then you get 2 here. 0. And then you will get 2. You will get 1 here, right? 2 divisible by 2 is what? 1, right? You get 0. And then you have 1 here, right? Then you will use 1 divided by 2. You get what? 0 here and 1 here, right?
Yeah.
So this is what you will get here, right? See number of bits you are getting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Not 8 bits, not 7 bits. You're getting more than that. So a byte cannot store this value. Okay. Okay, everyone. I hope it is making sense now, right? But again,
Yes,
I'm saying, I am saying that you do not have to go there. If you understand this part, like a byte stores 8 bits, a short stores in 16 bits, then this is of much value, right? From the understanding point of view. Okay, let's go ahead. Okay, let's go ahead. Now let me come very straight to the point. Like which of this you should use? You would be using maximum time this part. Okay, in 32 bits. Now you saw yourself, like if you have to use 16 bits, right, for short, it is already covering 32,000 minus 30,000 to some plus 32,000, right? Imagine 32 bits, right? Let me show you the number for this also. Data range for int variable in Java. See this value. I don't know how many digits is that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A crore has what? 7 zeros, right? so it has like 10 digits here. So it is like 100 crores. I think 214 crores something, right? I think it is a good enough number to store into int value. Okay. And if you have something bigger than that, then go to use and then start using long, right? You can see what values it stores. Okay. Right. But I think for most of your needs, right, int will suffice. So please use that only. Okay. Now, similarly, in case of float and double, right, you can see float uses 32 bits. Okay, 32 bits, and double uses 64 bits. Again, in most of your cases, when you want to use a decimal value like 5.63, right, the float will suffice your needs. So only use float there, right? If you think that you are going to use something which will not be fit into this kind of a range, then I think you can move to double part. Okay, but most of your thing would get sufficed with the float part. Okay, so the point I'm trying to make is, if you have to use within the integer family, you should be using int the most of the time, right? And in the case of decimal, you would be using float. Okay, And so now we are clear about integer family also, decimal family also. We have char, boolean, and we know about string. Let's do some examples on it, okay, to understand like how it all my day for branch, right? So I'm good to do this. So what I'll do now is I'll again see here, right? I do not have a package here. This is a folder, not a package. So what I'll do is I'll create a new class and I will say it as, let's say, data type demo. Okay, data type demo. If you do this, you will create main method, right? And over here, what we'll do is let's start creating some variables. First of all, let's try it on the integer family. So what I'll do is, first of all, let's start with the byte part. So I will use byte data type, the variable for it. Let me just not be very innovative about it. I will use just this a1 a2, right? A1, and let me provide a value. Let's say 567. Let's try this. Okay, let's try this. Whether can we do it? Okay, see here, it started complaining. Why? Okay, see here, it's saying cast expression to byte. Okay, let me use a smaller value. Let's say 56. Now you see, it did not complain, right, with 56, but it was complaining when I put the value as 128. Let's say it started complaining. If I use 127, I think it should not complain. You see, it is not complaining now because it knows that you are trying to create a variable of type of data type byte, and it can store this value safely. So that's why compiler is also happy and saying, okay, go ahead, you're okay to do it. But in the if you provide a value more than that, it starts complaining. And now I hope with that explanation you are understanding why this is happening, right? Now let's store this value, okay? And after this, let's store for the short value. Now for the short, I will assign a value a2, and again, what was the data range for it? Let's use that data range. Int, okay, let me grab for the int first. Let me grab this value, and let me provide a value whatever 67 as of now, and int a3 equals to this value, right? So it is not complaining, but as soon as I provide 8, will it complain? Okay, it is complaining. Integer number too large, right? So again, you would not get these kind of errors or these kind of information if you're using a simple notepad. Why are you getting all this information here itself while you're writing? Because you're using a tool which is an IDE, and this is coming from IntelliJ. And similarly, you will get the behavior in the, I think, other IDs also, whether it's Eclipse or something else. But again, try to understand the power of using an IDE. Okay, that's why we don't use a notepad. Okay, fine. So this is that range, and similarly for the double also. Let me use a double value a4, and let's try to use it. Let's say for double, what is the value? Oh, this is too much. No, I cannot write this. Okay, but I hope that you understand the point, right? So let me use 67, 679, and all that. Okay, fine. Now what will happen is, let's try to print this. Okay, or let's do some operations. What I'll do is, okay, let's try to do this. Okay, I will do one thing. I will say byte. I will create a variable, and these two are still int values, right? These are all int values. A1 and A2 are both int values, and I will try to make a sum of it, right? So what is the sum value? The sum should be 180, 194, right? If I add it normally, the output should be 194. But try to see here. If let me create another value A3, okay, of type byte, and here what I'll do is I'll do something like this: A1 plus A2. Okay. So A3 is already taken up. So let me get another variable A5. Okay. Okay, it is still complaining. It is saying that cast expression to byte. I'm sure people will not understand this as of now, so I'll not do it. But you can understand, right? Here, what we are trying to do, A1 is of type byte and A2 is of type short, right? And you are making a sum of it, right? And you're trying to put into a byte value. So it is something like this. You're doing something like this. You're saying byte equals to byte plus short. This is what you're doing. Byte takes 8 bits, it takes 16 bits, right? So overall, it will take 16 bits to do. But you're trying to store 16 bit into a byte, which is not correct, right? That is where it is complaining. Okay, but let's say that you are adamant and you want to store whatever the output you get, you don't care about the bits and you want to store it into a byte. Whether you lose some of the values from it, you don't care and you want to store it. And that is where it is giving an option to cast this into a byte. You do not have to understand this, but I'm just showing you as an option. What you will do in this case is, let me keep it as is. Let me use another variable a6, and what you will do is you have to do something like this. You can just click on this, and if you would see it, it did this and it is happy. Okay. Okay. As of now, just understand this is one of the options, right? And here compiler, we are telling compiler, okay, I am taking full responsibility of this output. Okay, whatever happens, it happened because of me. So compiler said, okay, since you are saying whatever output you get from this, you are converting that output into a type byte, so I will allow you to write this line. Okay, that is what it is doing. But what is casting means and all that, we'll cover that part in later part. Okay, so let me just, okay, let me keep it here as is, and over here what I'll do is, let me create one more byte. Okay, let me create one more byte. So this time I will create a byte of, let's say, A7, and I will assign it a value of, let's say, 10, which is within the range of byte. But if you add two these bytes, A1 and A7, what is the sum? 137, which is outside the boundary of a byte variable, which it can hold. So what will happen in this case? Let's see that also. Byte A8 equals to A1 plus A7, right? Now see this. A1 and A7 are both of type byte, right? Are both of type byte. But again, here it is complaining. What is the complaint? It is saying, no, mine is not int. Okay. Okay. Here it is saying that if you want to do this, right, use the cast part. Let me reduce the number. Let me say 12. Is it able to do it? No, it is not able to do it. Okay. See, the part is the value of A1 and A7, right, currently is 12 and 10, right, but if I keep, okay, here we know that the values are these, right? Let me create a method, public byte sum, and here I will accept two inputs, byte A, byte B, and I will do something like this. I will say return, let me create one more variable, byte C, okay, and I will say C equals to A plus B. Okay, now I want to return C. What is the problem in this? See, I do not have a value for A, I don't have a value of B, so my compiler does not know what value it may have, right? So it does not know, and it is saying cast expression to byte. Now see, a compiler here is taking some like precautions here, right? It is telling that, okay, currently I do not know what value you may provide to this A and B, right? Even if those values falls inside the range of a byte, but if you plus them, they may fall out from that range, right? So it is saying I cannot allow you to do it. If you want to do it, you have to do that cast expression, right? This thing, and what it will do is it will just add this, and now it is fine. Okay, so the point I'm trying to make here is that what you should do is that if you're working with bytes, right, you may find this situation and you may feel, you may scratch your head, okay, why I'm not able to add them? Because the reason is because compiler does not know what value of A or B it can have, so it is taking the other route of telling you, asking you specifically, please cast it to this kind of a situation, right, where you have to type byte. Okay, we will understand this, what is this, but as of now, let's understand that this is what you will have to do to get this sorted. But again, the point here is that you do not have to use byte anyhow. Okay, we are going to use only int for our integer values. Okay, so again, you saw all the problems here, right? Similarly, you will find the same problem with short. Okay, and the, I think not with the double, I think you will find the problem with short. I'm not sure, but I think you get that value for you get that errors for byte at least, right? Okay, let's use them. Let me just remove this. I don't want to just take more time on this part. Okay, and here this is byte. Let me remove this also. Now let's talk about this part, right? So I wrote all these variables, and if I want to print this, how I'll do is system.out.println, let's say byte is not byte, sorry, a1. All right, let's print this. It is building the project. See, byte is 12, right? If I store here 256, first of all, it is complaining. Let me convert this to byte, right? Let me do this, and if I run this as an output, let's see what do we get as an output. Let it run. I'm sure you will not get 256, but let's see. You got 0, right? You got 0. Now people may think, why did I got 0 here? Okay, I think again, if you want to understand this part, okay, okay, what should I do? See, what happens here is that you understand, right? 127, to store 127 value, you need 7 bits, right? We already saw that. And if you want to store 256, you will require, I believe, 9 bits, right? So what happens is that as soon as you got 9 bits, right, it will cut off the last 2 bits from that thing, right? And whatever you are left with, it just uses this and tries to calculate the value. And in the process, I believe that we are losing a lot of values there, and we are getting 0 there. If you want to see this, right, like, I can show you right away. But again, I'm not trying to teach you this part, right? I'm just out of curiosity, I'm just telling you, right, that this is how it happens. So 256, if you do, what do you get? You do, again, I think we have already done, so let's use that part only, this part, right? So let's take this part, right? How many bits you got? So how do you write this? So this is from here, right? 0 0 0 0 0 0 0 0 1. So see here, how do I write? So first 0 is here. How many zeros I have? 1 2 3 4 5 6 7 8 9. So there are 8 zeros. 1 2 3 4 5 6 7 8, and this is the ninth one, right? Now these are 9 bits, right? How many bits the byte can store? 1 2 3 4 5 6 7 8. Let's say it also stored the 8th one, right? So this is already gone. So what will be the output of this? 0 only, right? What did I told you? You find the index position first, like 0 1 2 3 4 5 6 7, right? And what we will do? You will do something like this. It is 0 into 2 raised to the power 0. 0 into anything is into what? 0 only. Now again, 0 into 2 raised to the power 1. Again 0, because 0 into thing is 0. Similarly, for all the things, you will get 0 0 0 0 0. If you add 0, what you get? 0 only, right? So that is where you are getting this 0 here, right? Byte is 0. Okay. So you have to be careful when you are working with the bytes and other parts. So the easiest part is use int. Okay, I think enough of it. Let's move ahead. How to use a decimal value, right? I want to store that, let's say, the weight of a person. So I will create a float value, because that is the data type which can help me to store a decimal value. Okay, and what I'll do is I'll say weight, and I will assign a value. Let's say 56.65 is my weight, right? And if you add comma here, semicolon here, you see an error. Now, what is the error here? See, the format of providing a float value, right? It is that you have to add an f after this. Let's first see the error. It is saying convert literal to float. Okay. Let's use this option, right? Then I will show. Provided. Okay. It is saying that you have provided a double value, but you're trying to fit it into a float value, right? Okay. I'll explain you like what is happening here, but let's use what it is suggesting to do. It is saying convert literal to float, right? It added an f here. Okay, and now it is happy. What is happening here is when you're trying to store a decimal value, right? So decimal value could be like after 6, right? 26 dot whatever you do, this becomes decimal value. 10.3 is a decimal value. 2.06 is a decimal value, right? These are all decimal values. Now in Java, what happens is if you try to assign this value as is, let's say you said float age equals to 10.3, right? Now what how Java understands is like if you wrote this as is, right, it understands that you are trying to put a double value. So if you want to store this way, right, 10.3, you should be using double. So here double age equals to 10.3 and it will not complain, it will help you, it will not complain, and you will be able to use this value. But again, the point here is that double will use 64 bits, double the size of memory which a float will use. And you do not have such need that you have to use so much memory for just storing a small value like this. So for you, the correct data type to use is float only, right? But if you have to store this value into a float thing, right, you have to do what? You will do something like this. In float age equals to 10.3 f. Okay, and now here our code is happy and it will allow you to do it here, but you use what? 32 bits. This is just a way with which Java compiler understands that you are trying to store a decimal value which is of type which can be fit into a float by providing an affair. Okay, and for double you do not have to add anything after this. Okay, again when it comes to decimal value you would be using float only, not this double. Okay, in most of the cases your work will be completed by using float only. Okay, let's move ahead. So we covered this part. Okay, now float weight equals to this. And let me just check, can I use a small f also? Yes, this also works, right? Small f or a capital F, it does not matter. You can use both of them to signify this. And if you have to use a decimal value, you will say decimal height, let's say height, and or not decimal, sorry, double height, and you will use let's say 5'7" right? Let's say. So again, it is not asking you to put f or d here. This is how it works. So we are done with the in family. We are done with the decimal values, right? How you use it. Okay, let's talk about Boolean, which is very quick. How you should use it. I'm audible, right? You can see my screen.
Yes, okay.
Okay, great, great. So we covered the Boolean part, right? The next easier part is to cover the characters, right? So now, if you have to store a single character, what you should use is there's a data type in Java which you have to use char, and you will add a variable, let's say initial name, like initial of my name, initial of first name, let's say, and I will store it. Let's try multiple things, right? If I can I store like a only, will it work? See here, it is complaining, cannot resolve symbol a. Okay, because here a is like a variable which you are trying to store here. So this will not work. What I can do is the correct format is you have to use single quotes and then provide a. Now it will not complain. Let's try to use double quotes. Let's see whether it works or not. You use double quotes and use a. Does it work? It does not work. Okay, and if you would see this, it is saying this string. Now in Java, right, if you are putting something into double quotes, it means you're trying to store a string value, right? So if you're trying to store a string value, the data type should be what? String only. But here we are trying to fit it into a char, which is not good, right? If you want to do it, you will have to change. Okay, here it is not giving an option to change it into this. Let me try. Can I do it this way? Char or no? No, it is not even allowing me to do this. Okay, so I cannot cast string to char. It is saying it is inconvertible. It cannot be converted. So again, another new point, right? So Java allows you to make that conversion from one data type to another, but there are certain rules around them. Okay, some of the things are possible and some are not. We'll talk about this, but as of now, just understand that when you're trying to store a character value, it will have to be this way only, capital A, let's say. Okay, let me use a special character. Can I use special characters? Yes, I can store a special character also. Okay, so if can I store a number into this? Yes, I can do that. Right, again 8 is also a character, right, which you can store. It is not only for alphabets or special characters. No, here 8 can also be stored. I'll show you one quick thing here, right? Let me do one thing. See here, not with 8. Let me do it for A here, right? This is A, small a, right? This is like an alphabet. Let me do int a ASCII value. Okay, so I will use what? I will use initial first name. See, it is not complaining. It is not complaining. See here, I created a new variable with a name which is of type what? Int, and I'm assigning this variable a value which is of type char, right? So it is like I'm putting a char value into an int, right? Let's see the output. What do we get? Are we going to see A there? Let's see this. Okay, so what I'll do is I'll remove this part and I will let S out, and let's add a ASCII value as an output. Let's see what do we get. Let's print this. $97, right? Let me use capital A. Let's print this. So A is nowhere compared to 97, right? But it is still giving 97. Now with capital A, it is giving 65. I'm sure you would have got the sense of it because I wrote ASCII value. So what happens is, like, all the numbers, all the characters, right, all the alphabets, right, have an ASCII value, right? So what is happening here is you use that character, right, and if you assign that character type to an int value, right, Java converts that character into its ASCII value and then assign it to the int value. Okay, let me show you the ASCII value. Again, I'm not going to explain like what is an ASCII value, but let me just see over the Google. ASCII value, ASCII value table. Let's see. Okay, this is too much to grab. ASCII value, ASCII table. Let's see. And if you would see, right, this is the full form of it. American Standard Code for Information Interchange, right, is a standard character encoding used in telecommunication. Okay, so ASCII controlled characters, ASCII printable characters, 32 to 126, most commonly referred to extended ASCII characters. So most of our alphabets, right, falls under this category, 32 to 126. Now let's see here. You see, every character has a ASCII code, right? Let's find the ASCII code for A, if we can find. You see A here, it shows the uppercase, the capital letter, right, has an ASCII code of 65. See here, what is your output? 65 for A, right? This is what is happening. You see, if you are trying to put a character value into a int type variable, what will happen is that character value, for that character value, the first of all Java will find the ASCII value and then put that ASCII value into this variable. Okay, so this is what it is storing now. Okay, any doubt on this one? See, there are a lot of questions, or there are a lot of programs, right, which an interview can ask, right, which are based on this logic itself. Okay, people can ask you, okay, can you do one thing? Can you, if you add 1 to A, what is the output? Let me do this, right? If I add, this would be interesting, right? Let's see. What I'll do is I will do something like this. See, currently what I've done is, let me show it on the board. If I go here see, what I've done is I created this char and I said let's say v1, right, equals to A. Okay, and then what I did was, let's say int v2 equals to v1. So in a way, what I'm doing is I'm trying to put a char value, a character value, into the int value. So I'm trying to stuff a character value into an int forcefully, right? What is happening because of this? This character, right? What Java will do in this case? Java will do what? Java will first see the ASCII value. Java will say, okay, you're trying to do it. Okay, let me try to do it in a better way. So what Java will do is Java will find the ASCII value of this character What is the character used? A. So Java will say, okay, let me find the ASCII value. The ASCII value was 97. So it found the ASCII value, and then it will assign this ASCII value to this int, which is of v2, right? Now your v2 will have 97. Can you assign int v1 equals to a? No, you cannot do that. You, okay, let's see. Actually, I am not even sure. There are so many permutation combinations. Let's try. Int v1 equals to a. Yes, this is possible. Great. Again, one more possibility. Again, what this v1 will show? This will show 97. Let me print this.
65 value.
Oh, sorry, 65. Yes, sorry. I am not good in remembering the number. So, okay. So, it will print 65 again, right? Yes, 65 again. It printed 65. So, Sangeeta, yes. So, this is how it will work. Okay. And, but I wanted to show you one more thing. What if I add a number, if I add +3 on it, let's say, let me remove this, or let me keep this as is. What I'll do it now is, I will do what? I will do something like this. I will say v1 equals to v1 plus 3. Okay. And then what is the output now I'll get? So v1 was 65, right? So the output of this line was 65. Now I will have what? 65 plus 3, which will be what? 68. Everyone is on with me with this part, right? Now v1 will be 68. Right or no? Any question on this one, right? From anyone? Right? Everyone
Yes.
understand this part, right? Now let me do this. Here v2 equals to v1. Okay, let me do the conversion part. Cast expression to char, right? And let me print v2. What should I get as an output? Let's see. I'm not sure. Let's see. D, right?
Right.
So what happened here? So what happened here, right? Now in this case, we are trying to stuff our int value into char, right? So now the opposite is happening. It whatever value you had, right? Java tried to find a relevant character for which that could be its ASCII value, right? So 65 was the ASCII value of 8. 66 is the ASCII value of B, capital B. 67 is the ASCII value of C, and 68 is the ASCII value of D, right? And that is why you are seeing B here as an output. Okay, this casting part, right? This is very important when we'll talk about a lot of things in the Selenium part. If you all remember, if you're taking a screenshot, right, that code over there, right, looks like something like this. You have a bracket in front of it and you write screenshot as in whatever that is. I don't even remember the syntax, but that is where it is, right? Even with the JavaScript executor part, that is where that thing comes in, right, where you have to cast it. So there that casting is happening. Okay, we'll talk more about casting when we talk about more in detail about classes. But here, try to understand what this casting is doing. Casting means that you're converting one thing into another forcefully. Okay, that is what it means. Here I'm trying to convert my int type value into a character type by performing the cast. Okay, I think we are good with this part. So we covered boolean, char, and all this, right? The last part is about string for today. Okay, so how do you create a string variable? You will say string. Now, okay, string, and then you will do what? You will say string, and let me say name, and you will assign a value, let's say Akhiljan. Okay, so this is how you create a string variable. Can you use single quotes here? Let's try. No, you cannot do it. Okay, you cannot do it. Okay, can I store a value of char into string? Can I do that? Let's try to do that also. Can I store initial first name into a string variable? Can I do it? It is not allowing me to do it. It is saying what? Wrap using Java string value of. Okay, leave that part. Okay, so again, it is not possible here to do it this way. So what you can do is you will have to have double quotes and you will have to add the value inside this. Okay, and how do you print it? You will say just name here, right? And if you run this now, you get this output. Okay. Now one last thing for today, which I just out of, so that it can bring some more curiosity. See here. Until now, I was creating these variables, right? I told you all these variables here, right? All these data types here are of primitive data types. And when I said primitive, it means that these are not classes. Okay. Now, if you remember, right, in our case, when we were talking about when we created classes yesterday, how we were able to access the methods. We were creating the object of the class, or let's say the class name. We were putting a dot after it. And once you put a dot, you get access to the methods which are available within that class. Right, everyone? Any confusion in what the statement which I made now?
No.
Okay.
We all agree on this part, right? Now, okay, we all roughly we agree, right? Yes. Okay. Okay. So now, what I have to do is now see here. If I use v1, which is of type int, right, which is not a class, right, which is not a class currently. So if I use v1 and I put dot after it, can I access any methods? These are not methods. Okay, these are not methods. These are just helper information which is coming from id. These are not the methods which are coming from that int type. Okay, none of these are methods or variables coming from the variable. These are just some helper things which are coming from the id. Okay, so v1 is not a class or an object through which you could access the classes, or sorry, the methods or the variables. Okay, so it proves that v1 here are what? Are not classes. This is a very good way to understand whether something is a class or not. You just use the variable, right, which is used there, and put a dot after it to understand. Now let's try it for name. Name is of type what? String, right? S is capital here. Let's do name dot. Now see this. It shows so many methods. You can see m here, right? M here represents that these are methods. Okay, and for the variables which would be there inside this, if there are any variables, I don't remember. See how many methods it has. These are all coming from string class, which you did not create it, which Java is providing to you. Okay, there are so many, right? Okay, there are so many methods only. Okay, I do not see a variable. Okay, great. There are nothing. Okay, now there are so many methods. Let's use one of the methods. Let me use one of the methods. One of the method here is to, let's say I have this name, right, Akhiljan. I want to print everything into the uppercase. So there's a method inside the string class which you could use to uppercase. Okay, and you can provide name here. Okay, and this should get printed as out. And if you run this query, right, this time what should it print? It should print Akhiljan, but all in caps. This is the power of class that you could create here. Akhiljan, all caps, right? And let me show you the string class also. In when you're using an IntelliJ ID, right, this ID here, what you can do is, if you want to see the code of the classes which you did not create it, but Java is providing you, right? See, it is not very easily. I mean, you cannot see those classes easily, but using these IDs, you can do that also. What you can do is just go over the string, press Control from your keyboard, and click on it. Now see, it will open up the class which someone at the Java side would have, developer on the Java side would have created. See here. Now you can see the person created this class string, and it is a class, and there's a final keyword use. Again, we'll talk about final on, but again, see here, right? String is a class. Okay. And if you try to do the similar thing for int here, right? Can you do this? No. It is, I'm still pressing control and trying to do it. There is nothing here, right? So the only thing in Java which is not in class or an object, right, are these primitive data types. And this is the core learning which you should have for today. And apart from like what we learned, right, how everything gets, I mean, how these values are getting stored and everything. Okay, this is what I wanted to share today. There is nothing more. I think this was a fun class today, but and I hope that you enjoyed this. Okay, any queries on this one? No? Please practice this, okay, at your end.
One question.
Yeah, please. Yeah, please, Atif.
One question, Akhil, like to have different data types in Java, what I can understand is to have better memory management, because That is the only reason. To have
For within it is you can say that statement for, let's say, for the int family, right? You have 4 options, so whatever suits you best you can use that, right? If that is the memory management part, if you're concerned with that part, right? But if you have to store a character value, right, you will not store it into a int, you will still store
yes,
it in the character only, right? So
yes,
whether
and
character, and I
correct.
think character takes how many bits, I don't know, I think it takes 16 bits, I believe, but that is how it is. Okay.
Yes,
Okay, and similarly that memory management thing comes in the process of any combination database, or is there any restriction? Some, can I do data type casting in any combination? See, it depends, right? Again, we'll talk about the rules of casting, but maybe it will take a couple of days more to get there. But yes, we'll try to understand like what is possible doing by casting or not. It has to be compatible. In the end, it has to be compatible. It has to follow the rules of Java. If it is compatible, then it is possible to do any complex casting there. Okay, that you are adding a float, int, and all that, and you're trying to get in the out in the end, you want to store it into an int variable, right? So we'll see like how you can do it, but again it is possible actually. Okay. Okay, anything else, Atif? You got your answer?
yes, yes. Okay.
Okay, okay, great. Okay, I think if no questions, then I think we are good for today. Let's meet tomorrow. And tomorrow, I think, as I said, right, what is the objective? Let me actually see this. The objective is to learn,
Types of classes.
no,
Sorry,
the methods, right?
Yeah, methods.
Methods. Okay. The assignment for today is please practice by creating different types of variables, right? Try to convert or provide one data type into another, right? And try to see what failures do you see, what kind of compilation errors do you get. Okay. Try to learn from your mistakes here. You will get a lot of insights by doing just all these exercises also. Okay. And if any queries, we'll talk tomorrow. Okay. Great. Thank you everyone for joining today. Let's meet tomorrow. Good night. Take care. Bye.
Bye-bye.
Bye. Bye.
Thank
Take
you.
care.
Bye.
Yeah. Thank you. Bye. Take care.
Thank you.
Bye.
Bye.